Hello everyone, and thank you very much for joining our webinar today entitled Pushing LTE to the Next Level. I'm Caroline Gabriel, I'm the Research Director at Maravedis-Rethink, and I'll be your compere today. Maravedis-Rethink will host the webinar today and share some of our latest research findings from two of our leading research services, MOSA, that's Mobile Operator Strategy Analysis, and our RAN service. We're also delighted to welcome our guest speakers from Yota Networks in Russia, Konstantin Yurganov, Chief Technology Officer, and Maksim Kumskoy, Senior Expert in Mobile Communications. Yota is particularly interesting in the evolving world of 4G networks, as it had early experience of deploying commercially successful mobile broadband using WiMAX. It has now deployed LTE and is already implementing elements of LTE Advanced, as we'll hear later, and it supports a pioneering wholesale and RAN sharing model for Russia's mobile operators. As such, we regard Yota as a trendsetter within the 4G operator community, as tracked in our MOSA service, which examines the infrastructure rollouts of the top 100 4G carriers worldwide. Before we start on today's presentations, we'd like to run a quick poll to find out more about you and our audience today. If we could run that now, Adeline. You'll get the opportunity to vote at any minute. Great, I can see as the votes are coming in. Got quite a proportion of hardware and software vendors today with us. Just wait for the poll to close. Great. Yes, quite a vendor audience today, 47% hardware vendors, but it's also got nearly 1/5 operators. So quite a good mix, and I'm sure that the presentations will address the interests of the whole audience. This is the agenda for the call today. Some key findings from our research services, looking at early moves towards LTE Advanced and other aspects that we hope will tie in with what Konstantin and Maxime will tell us about later. Then Adeline will give us some highlights of the MOSA service, and then of course we will go on to the operator presentation from Yota. That will be followed by Q&A. And can I remind you, you can submit questions at any time by typing into the questions box. We'll try and address as many of these as possible at the end of the session, but I'll just show you a couple of housekeeping slides on the technical side. The most important here is that question box, which you can see at the bottom of your dashboard. As I say, please type in the questions, and we will try to get to them. Otherwise, I think it's fairly self-explanatory, but you can see the grab tab at the top. That's if you want to open and close the control panel. And some commonly asked questions. Can I obtain the slides? Yes, you'll get an email after the webinar, and that will have a link to download a PDF of all the slides that we show today, and also a link to watch the recorded webcast. So those should happen within the next 2 business days. And please visit our website for further information about all the research that we discussed today, and there'll be more contact details on the slides later on. So please take advantage of that to contact us with any questions. We'll now go on to another poll. We're going to conduct several polls through the course of today to get some interaction with you and learn a little more about your needs. So the first of these is looking at a very common and important topic for all of us, wireless backhaul. As you'll see, we're looking here at what will be the most common wireless backhaul technology for small cells and metro cells, particularly when those are being deployed outdoors, usually in urban environments. There are quite a few bands, and we're very focused today on Russia and CIS, which has some very particular spectrum and licensing conditions. So we may see quite a different outcome to what we've noticed when we've previously done this poll. So we'll be interested to see that. That's still open, but even as it is, I can see that it's quite sort of level pegging between the E-band and the classic microwave band. So closing the poll there, and yes, the E-band, which is up at 70 to 80 gigahertz, That's emerging at over 1/3 of the audience think that will be the most important metro cell backhaul band. The PMP microwave and point-to-point microwave bands are about equal there, with about 1/5 each. So quite a mix, but a definite strong preference there for using the E-band, which is very interesting. Right, I'm now going to set the scene for Yota's presentation with a few highlights from our most recent surveys of the top 100 4G operators. I've selected a few themes just for 3 or 4 slides, but I hope that these will tie in with what Yota is going to talk about and set some context for that. So first of all, the need for new networks. Yota is pushing ahead with some quite radical approaches to building 4G networks and using quite a lot of small cells. Why do we need these type of new networks? It's quite a familiar story, of course, the capacity crunch, coupled with the need to invest in a lot of capacity but still make a profit on it. So on average, operators are looking to reduce the cost of delivering data at least by 50% within the next 4 or 5 years. But at the same time, they are having to vastly increase the amount of data capacity that they can offer. One message that's clear is that they can't rely on spectrum alone going forward. Although there are many efforts to open up new spectrum bands, this will certainly not be enough to meet the capacity demands of 4G. So you can see on the graph opposite that while in 2013, new spectrum and spectrum refarming emerge as the most important contributors to extra capacity. But as we get to 2017 or 18, carriers are much more focused then on ways to use their existing spectrum more intelligently with techniques such as carrier aggregation we'll hear about more later. Other methods of addressing the capacity crunch involve radical new ways of thinking about building and planning networks. Certainly it involves lower cost, commoditized hardware, but also greater reliance on intelligent networking to use those resources as efficiently as possible and allocate them where required by the users. Using combination of spectrum bands and of course integrating the license-exempt technologies like Wi-Fi. So all these elements are building up towards a full HetNet strategy. For many operators, small cells are absolutely at the centre of these because of the relatively low cost contribution they can make to targeted capacity and better coverage. However, while there's been steady growth in femtocells and the private access small cells, there's still a big gap between the early adopters of the public access, what we call metro cells, and mass market adoption, and these metro cells are what will really transform the nature of the carrier mobile network. So we can see from the graphs on the right, the one on the top is a forecast from 2 years ago of deployment of public access small cells, and the one on the bottom is a recent forecast. They get to about the same point in terms of the volumes deployed, about 3.5 million units in our estimation. But as you can see, there's a far slower start. So up till 2015, really they're just some very cutting-edge early adopters, but the mass market of carriers holding back rather cautious, and particularly there's a shift towards deploying indoors first rather than outdoors, because the indoor market is slightly less complex in terms of backhaul, site acquisition, powering, and so on. So what's needed to kick-start a bigger, wider adoption of metro cells? Certainly more system-on-chip platforms to bring down costs, more streamlined processes of acquiring sites, some mutual host approaches where one carrier builds a network and supports small cells for many. We also think LTE Advanced, as Yota will look at, provides some critical help with making small cells sort of easier and potentially safer to deploy in business terms. Factors like EIC, standardized approaches to self-organizing networks, anything that really allows the small cells to organize themselves, to avoid interference, to work more happily with the macro network. And although there are good proprietary techniques that operators are using in their deployments, of course those are costly, so these things need to be incorporated into standards. But many challenges remain even at that point. Roaming and interaction between different types of self-organizing network methods is a major challenge, and also working happily with macro networks from multiple vendors and operators. So it's not going to be easy, but we believe that some of the LTE Advanced standards will be a useful catalyst. So we can see that in this slide. LTE Advanced, of course, isn't a unified standard or a big leap. It's a menu of options, and carriers will choose from those according to their requirements. Here we look at some of the key features of LTE Advanced and how much uptake we expect them to have among 4G operators. I think the overall message from this, don't need to go to the details, but the ones that get early adoption on a mass scale tend to be those that are either connected with making small cells more deployable, such as the ICIC, or those that are related to making better use of your spectrum, so things like multiband, carrier aggregation. These are the areas of LTE Advanced that are getting lots of early attention, while some of the others will be seen as optional until later on, until 2017 or 18. There are some cutting-edge deployments, of course, but mass uptake, as with any new standards and technologies, will require device support on a broad level, operator confidence that they're not going to be in a technology island, they're not taking too many risks, and a lot of that comes down to interoperability testing to ensure that they'll have a network that can roam with that of others, and that they can buy equipment from any source. But overall, the focus shifts more and more to software and to using these new technologies intelligently. So my final point is hardware will commoditize, and differentiation moves to putting intelligence from the core to the backhaul to the edge of the network, harnessing all that capacity. Capacity in the network and the spectrum will always remain more limited than we need it to be for rising data demand. So it's a question of using it more cleverly. So with key trends like caching content at the cell site, the emergence of carrier software-defined networking, and advanced techniques for SON and optimization. So on that note, I'm going to stop. I hope I've set the scene usefully there, and I'm going to hand over to Adelaine Feller. He's going to run a couple more polls and also share some highlights about our MOSA service before we hand on to Yota.
Thank you, Caroline.
Presenter now.
Thank you. I'm going to run a second poll here. Please take a few seconds here to answer question about whether you are familiar with the MOSA service, which is the platform that supports this kind of activity today, the webinars and the relationships with operators. MOSA stands for the Mobile Operator Strategy Analysis Service. So I'm going to close the poll now and share the results. Only a few minority here is familiar with MOSA, so I'll just take the next 5 minutes to explain what MOSA is about. So the service, which stands for the Mobile Operator Strategy Analysis, is actually a service that tracks in detail the wireless infrastructure strategies of the top 100 4G operators. And so the service looks at different aspects of the wireless network. We, of course, include analysis of the macro RAN, the evolution towards small cells and Wi-Fi, the links, the different technologies linking those sites, whether they're wireless or wireline, to the backhaul, and the core network. The analysis of those different aspects of the network leads to a SWOT analysis of operators and ranking of the leading vendors from the perspective of the operator, from the perspective of deployments. This is not a shipments ranking of the sort. We also have a very strong regulatory and spectrum analysis practice, and so we also analyze spectrum holdings of the different operators. In terms of the structure of MOSA, we try to maintain a very simple flow of analysis in what is a very complex environment. And so we look at the drivers and challenges that are facing the mobile operators and look at the solutions that are emerging, whether those solutions and challenges are technological or spectrum-wise or business-wise. Out of the top 140 operators, we have identified a number of leading operators, ones that are really driving the ecosystem, pushing for innovation, investing and putting their money and clout on the table to make things happen and solve their own issues around essentially 10 key areas in the network that are listed here, whether it is small cells or carrier Wi-Fi or LTE Advanced, and hence the participation of Yota today as one of the leading operators covered in the service. In terms of information flow, our objective is to produce reliable data, and that comes from the operators themselves. And as you can see in the flow chart here, everything starts with the operator's input, and that input comes in the form of either interviews with the operators as well as information part of our internal modeling tool, where we capture a lot of the variables in terms of forecasting subscribers, then determining the number of cell sites, which is increasingly important in the aspect of small cells and the proliferation of street assets, leading all the way to CapEx estimates for the different flavors of cells as well as backhaul. In terms of deliverables, we have a number of them, the first of which are the detailed infrastructure profiles, such as here the AT&T. They come in the form of a mini report where we include detailed analysis of different aspects of the network that I have mentioned. That includes forecast by operator for the number of small cells or micro cells, and detailed information of their CapEx plans as well as the different issues they're facing, remembering the equation of drivers plus challenges leads to solutions. And that includes, of course, also spectrum analysis, which produce a result of SWOT analysis for each operator. In terms of second deliverable you get is quarterly reports, one of which the next one will be delivered at the end of towards the end of this month, where we essentially analyze the evolution of the market trends in the last quarter for all of the top 100 operators, summarizing trends both qualitative and quantitative, which includes the trends and forecast. And there is a number of case studies of the leading operators depending on the key areas we're covering. The third deliverable is a detailed spreadsheet, which includes information of the top 100 operators. For example, here I'm showing some of the detailed spectrum information, exact frequency bands, for example, their deployments, information by band, technology, subscribers, and again following the flow of information to produce reliable CapEx forecast. And that comes in Excel and includes information of all of the operators we're looking at. I'll be happy to, of course, provide a live demo to parties interested. The fourth deliverable includes a detailed analyst briefing of the key findings every quarter by the team, as well as very proactive and in-depth analyst support. There is an interest in a live demo or more information, please don't hesitate to contact me at the information provided in this slide. Thank you.
Great. I think we're going to run a final poll before we hand over to Yota. This one is looking at one of the key topics today, which is small cells. You see it in front of you. This relates to a slide I showed a few minutes ago, which is about public access small cells as opposed to the residential census cells. So we're interested to see whether your views reflect ours and whether these will be deployed on a wide scale as opposed to by a few cutting-edge operators, as we believe is happening now. So I'm seeing the results coming in as we look at them. Yes, well, there's an overwhelming consensus here, which is that the tipping point will come in 2015 to 16. Two-thirds of the audience are looking at that time frame, and I think that very much reflects what our research is saying. So that's an interesting finding. So thank you for that. Well, Adeline passes control over to our speakers. I'd like to very much welcome Konstantin Yurganov, CTO of Yota Networks in Russia, and Maksim Kumskoy, who's Senior Expert in Mobile Communications, also at Yota, to share their experiences and plans.
Hello. I welcome everyone who joined this session. This is a little bit new format of a public presentation for me, but I hope that everything will be good from a technical point of view. My colleague and me will present you some of our technical ideas and innovations, and we will try not to be boring. Sorry. Okay. For the beginning, take a quick look at our history. The company's cartel brand Yota was founded in May 2007, and we started as a 4G internet provider via WiMAX technology. In 2 years, we had a commercial launch with WiMAX in 5 Russian cities, including Moscow and St. Petersburg. But after some time, we became disappointed with WiMAX and decided to develop LTE instead of WiMAX. We made this decision because of many reasons, but main of them are user equipment ecosystem and mainstream for data and voice over LTE for main industry telco operators. We received LTE license, changed our frequencies from WiMAX to LTE FDD 2.6 GHz, and in December 2011 we launched our first LTE city. The next important thing in our history is an agreement with Megafon, this is one of 3 biggest operators in Russia, about a partnership. There are 2 main parts in this agreement. Firstly, we could use physical infrastructure like towers, place for installations, backhaul channels, and so on from Megafon to constrain our network. And secondly, we sell 4G traffic to Megafon as an MVNO operator. So all our LTE cities, we started with 2 MVNOs, Yota and Megafon. At the moment, we cover with LTE FDD 2.6 GHz 124 Russian cities with population more than 29 million people. And summary traffic from 2 our MVNO partners, Yota and Megafon, is more than 76 gigabits per second in a peak time. And we're also still open for new MVNO partners. Let's talk about the evolution of network construction approach. Most common situation in past when each operator built its own radio networks, which includes site acquisitions, purchase of hardware, and construction of transport network. It took a lot of work, time, money, and efforts. In some cases, operators try to save money and to speed up the construction by sharing sites. But the best economy effect could be reached by sharing the same base station and radio resources, and of course the same construction sites. This is the best solution from the point of view of fastest time to market and minimal capex and opex. And currently, as I told, we are sharing sites and transport network with Megafon, and from the other side, Megafon and Yota are using our LTE network in RAN sharing mode. Based on this point, we decided to split our company in two different business units. One of these units concentrates on customer services and effective marketing programs. Another unit concentrates on effective network construction and maintenance. And later, this business unit started like two companies, Yota, this is 4G operator, and Cartel, brand Yota Networks, infrastructure company and wholesale operator for different companies. It allows each company to focus on its goals. And we are presenting Yota Networks company. As a wholesale operator for several MVNOs, Yota Networks has two main key focuses. Provide radio network for several MVNO operators with full sharing options and full statistics. And the second key focus is construct, maintain, and provide radio access network with the best quality and efficiency. Let's talk about technical details in our innovations that support these key focuses. And our technical expert, Maksim Kumskoy, will present the second part of this session.
Okay, hello everyone, this is Max, and I'm sorry, and I will speak more about technical details about what we are doing. So let's first talk about sharing radio network for several MVNOs. As Konstantin has just mentioned, this is one of our global tasks. Let's look at this picture from bottom to the top. Now we have two MVNO operators, Yota Russia and Megaphone. Yota Networks has built an LTE network and share between these two operators. Transport network is also shared between operators. Some LTE sites are built on Yota Networks network, and some sites are built on Megaphone. And as you can see, each operator has its own core. Megaphone has 2G, 3G, 4G core, and Yota Russia has a 4G core. So it's clear with the core network. Let's now talk about radio network. In our solution, we took into account the following principles. The solution has to provide maximum spectral efficiency, guarantee fair sharing of resources, and protect one operator from another, and provide confident QoS without interference between operators. So let's look at the illustration of the principles which I have just mentioned. So on the first circle, we have an example configuration how to share resources between two operators. We can now configure a guaranteed percentage. In this example, it's 50-50, which means that in a congested cell, each operator can get up to 50% of resources. Well, this configuration is flexible, which means that if one operator doesn't require some resources now, another operator can take its resources up to 100%, and this helps us to maximize spectral efficiency. The solution also protects operators from each other, which guarantees fair sharing. This means that once operator B comes back and he needs his resources, operator A will be shrinked and the proportion will be back to 50-50. Okay, so now let's move to another big goal of Yota Networks, which is to provide the best network quality and efficiency. This task is split into 3 directions: improvement of spectral efficiency, quality of experience, and network management. And let me go through our technical initiatives that are aimed on these tasks. So first, let's start with LTE Advanced. LTE Advanced is clearly to improve spectral efficiency and thus subscriber bandwidth. In October 2012, we have a demo in Moscow. We made a commercial LTE network and LTE Advanced network work together. And we set up carrier aggregation for 40 megahertz and achieved subscriber peak throughput up to 280 megabit per second in downlink in a real network condition. Additionally to that, we did MIMO 4x4 tests. We had a setup on 15 megahertz and we achieved up to 180 megabits per second in downlink, which is in average 50% faster than MIMO 2x2. So in plans for LTE Advanced, we have testing of carrier aggregation scenario for 800 megahertz plus 2.6 giga, and we would like to see LTE Advanced capable devices. Another project which is aimed on the spectral efficiency and the network capacity is HetNet. You know that small cells is an effective solution for outdoor, which may increase capacity and performance mainly, and also help to extend coverage at some point of interest. Well, for indoor, which is covered by picocells, we believe will be very helpful to enhance indoor coverage for voice over LTE. But these days, when we have LTE only picocells, they are not really beneficial over traditional Wi-Fi. Well, to make small cells work effectively, we need to take care about the following issues. First is geolocation, which means that due to small power and small radius, the correct location is really critical for small cell. The cell should be installed in a position where both traffic and subscribers are. Otherwise, it doesn't give any benefits. And the main problem is to search for such positions. Of course, there is a manual search, which is quite inefficient and very time-consuming. And on the market, there are some automated solutions, but they work pretty well for 3G, but we didn't get yet good results with our 4G case. Another issue which we need to think about is macro network optimization. Of course, it is better to use a dedicated frequency for microcell. But if it's not possible, then we need to think about macro network optimization. Otherwise, we will have a very huge interference between micro and micro cells. The last thing is fast and cost-effective deployment. So when we speak about microcells, it's not a good idea to deploy them on rooftops. So we need to search for new locations, new sites, such as billboards or maybe light poles. And if you want to use that sites, traditional optic backhaul doesn't work. We need to think for non-line of sight backhaul. Okay, so we talked about improvement of spectral efficiency. Let's now talk about improvement of quality of experience. congestion management is an example of a joint project between operator and Yota Networks. The goal of this project is to improve the quality of experience in a congested cell. We have done pretty much of tests to find out the best solution how to cope with congestion. And we began with semi-static policies. We did tests with limitation of peer-to-peer traffic on the whole network. We did tests with prioritizing subscribers in something like gold, silver, bronze model, but none of that really helped. So now our idea is different. We want to differentiate services and not the subscribers. For example, at one particular subscriber's traffic, we will prioritize video, web, and DNS requests, and we will deprioritize peer-to-peer traffic. And this is really improving the quality. We have tested this mechanism in most congested cluster in St. Petersburg, and we have seen significant results. Another way how to help improving the quality of experience is internet traffic optimization. The main purpose of this project is the video traffic. So the video experience. The goal is to get rid of stalls, because there are too many factors which can limit video quality of experience. It can be anything from poor network conditions to slow data plan, but disregarding what caused the limitation, result is always similar. User is suffering from the stalls. So we are testing video optimization solution which have the following features. It has a feature of adaptive compensation, adaptive compression, sorry, which adapts video quality to the bitrate which is really available to a subscriber. Another function is smart buffer control, which helps not to waste network resources for caching video in browser, because maybe the user won't watch it. And the shaping function, which helps to limit the video downloading bitrate to the bandwidth that is really required by the video. In addition to this, we also check out on web optimization features, and some of these solutions have been already implemented in our network. We've spoke about the quality of experience. Now I want to move to network management. To achieve our goals, we are looking for the ways how to automate and simplify network management. First of all, we are testing solutions for automated spectral optimization. Well, this may be a closed or open loop system that will analyze and generate solution for optimizing radio network, power, tilts, and so on. Secondly, we are working with vendors to solve our geolocation problem, which we have discussed a few slides ago when I spoke about microcells. The other important things that we have successfully tested and launched is LTE INR, and now we are testing inter-RAT INR between 4G and 3G networks, which helps with CS fallback mechanism. Another thing what I wanted to talk about is monitoring of transport channels. So in our case, when we need to ensure KPIs of radio network, we need to control end-to-end KPIs on the transport channel. And in our environment, when we have a distributed responsibilities between MVNO operators and the Yota networks for transport, we really need to have this end-to-end feature which will monitor KPI and SLA. And the last slide, but not the least, is Walter. I need to say that we are now getting ready for a demo for IMS voice with SRVCC function. We have completed IMS tests in lab. We have seen rich communication suite clients, and we are ready to test single radio voice connectivity once we will have a capable user equipment. Well, this is all I have to say. Now I pass the word to Mr. Yurganov.
Okay, thanks, Maksim. This is all about our technical innovation for this presentation, but of course it's not all of our ideas and not all of our technical innovations. We also share our experience on different branch events, face-to-face meetings with operators and vendors, and in Next Generation Mobile Networks Alliance. I hope that our ideas and practical experience could be useful for other operators. Thanks for your attention, and now we are ready to answer the questions.
Thank you very much, Konstantin and Maksim, and yes, I'm sure that a lot of your ideas will be of great interest to other operators. You've taken an advance in many areas. To the audience, please, you still have a chance to type in your questions in the questions box at the bottom of your dashboard. So, do that. We've got quite a few questions coming already. Where there is similar, I'll try to group them into a single question. So perhaps to start, Konstantin and Maksim, please answer whichever you feel suitable for the question. But we're wondering what additional spectrum would be valuable to Yota in the future for access or for backhaul.
Okay, let me introduce another my colleague, Alexey Mirkhanov, and he's an expert and he will answer this question.
Great.
Hello everyone. So in terms of additional spectrum on the Russian market, I shall say that we're not discussing the frequencies being available for the particular company, but in general, in our country, we think that the next spectrum allocations would be 800 megahertz, which would be especially important for both voice over LTE rollout and also for the coverage of rural areas. And also, there may be an additional bands being allocated in 2.6 gigahertz in TDD LTE, which may be useful for wireless backhaul solutions, but potentially for other services as well. I think that's pretty much our understanding of the future frequency plans in Russia.
Thank you. Moving to, you mentioned VoLTE quite extensively. When do you expect a full commercial launch, and are there still challenges to overcome?
Right now, we had already launched a CS fallback service, so with appropriate user equipment with newly available smartphones, subscribers can already use both high-speed LTE access and use the usual 3G voice services on the smartphone. And I think that the main issue for the voice over LTE in Russia is the availability of the devices which would support voice over LTE, and also the lower frequencies, because for a good user experience it's necessary to have a wide LTE coverage, and allocating the lower bands like 800 megahertz for the LTE would allow us to expand this coverage to rural areas and improve the indoors coverage as well. So I think once both of these issues are resolved, both by the market and by the government agencies, there would be no other blocks to launch the service.
Great. There are, related to that, there are quite a lot of questions about devices. Do you find it hard to get devices that make full use of your network and its functionality?
Sorry, could you repeat your question?
Yes, I'm wondering whether there are problems to find devices that can make full use of your network and all the functions of LTE.
We have an open market for devices, and the amount of devices is really growing.
And of course, nothing special in our networks, and we support all kinds of devices on the market, and all our technical innovations and all our technical features depends on our core and run network, but it's really work with all devices on the market with LTE.
Great.
Only maybe some features with LTE Advanced, of course, connect with device side, and we are still waiting for chipset and devices with support carrier aggregation and all another feature of LTE Advanced.
Sure. How long do you think that will be?
This is a question for the chipset vendors. We expect that in the end of 2013 it should be a chipset with support carrier aggregation. That means that in the first or second quarter 2014 we are expecting to new devices with support carrier aggregation and features of LTE Advanced.
Great. And a final question, which is how you will address the challenges of roaming with other networks, if they're in Russia or in other countries?
Well, I will say that this is two parts. There are two parts in this question. So, firstly, when we talk about the international roaming, the main difference with LTE is while we're using it for the data services, there is a little need for any kind of device or user identification, which is absolutely required for the voice roaming, for example. So when you're traveling abroad with data-only device, with data-only services, you are not expecting to keep hold of your IP address or whatever other identification you have in an IP network. So it means that on the operator side there is little urgency about introducing the international data roaming. And I think that additional services, the new services such as voice over LTE, would be a biggest driver for the change in this respect. So once LTE voice becomes a typical service on the market, we would expect agreements between major players, major international operators to surface. On the other hand, you mentioned various bands, and that's a different story. We see more and more vendors, device vendors, support multiband devices, which means that as time goes by, it would not be a difficult task to find a device which would operate in many frequencies, which means traveling into the areas with different frequency bands would not be an issue. And also I think that with the introduction of carrier aggregation, the interworking between frequencies would also be a good advantage to both the user and the operators.
Great, thank you. That's really interesting. And in fact, we have one more question that has just come in, which we'll close with, and that is, with your shared backhaul network, how do you monitor the SLA service level agreement on that network?
Of course, we have a detailed SLA with our MVNO partners. This SLA split on several parts, from the backhaul and other infrastructure that we rent from our partners. The one part of this SLA, and from the RAN part and radio part, there are another portion of the SLA, and of course we have all the SLA via our contract, of course, but I think this is a term of another detailed presentation, how to manage this SLA and how to define this SLA in the contract point of view.
Yes, I agree. It's an interesting area in your model. Great. Well, apologies for anyone whose question didn't get answered now, but I hope that we can follow up privately. Once again, please do contact Adelaine or myself with any follow-up, or if you'd like to have a demonstration of any of our research. It just remains for me to say thank you very much to everybody for attending today. It's been a great session, and certainly I found it extremely interesting. So finally, I would like to thank Konstantin and Maksim and their team very much for spending the time with us today. That's it for now. Thank you and goodbye.
Thank you.
Thank you, goodbye.